Thanks for joining us here in the All Lines Technology Tech Talk breakout room. It's a pleasure to be here, have the opportunity to introduce our distinguished speakers today. My name is Brant Gall with All Lines Technology. For those of you who are unfamiliar with who All Lines Technology is, we're a local, woman-owned strategic IT solutions provider who has been a member of the Pittsburgh Tech Council for, I believe, 9-10 years. So All Lines Technology, when I say we're a strategic IT solutions provider, what I mean is, as a company, our goal is to truly partner with our customers with the initiative to work with them to strategically plan their IT strategy. In today's world, as we've learned throughout the day, big data isn't just a buzzword anymore through leadership groups across companies of all sizes. Being an end-to-end IT solutions provider, All Lines Technology has the ability to help companies harness the power of big data to strive for their business goals. So furthermore, All Lines Technology portfolio consists of MSP, including 24/7 help desk services, cloud hosting services, infrastructure as a service, DR as a service, BI, which ties in perfectly with the big data discussion, and IT, enterprise IT infrastructure. So without any more, I'd like to take the opportunity to introduce our first speakers from the Pittsburgh Supercomputing Center, Paola Buitrago and Nystrom.
Good afternoon. Thank you, everybody, for coming to our talk. Today, I will be talking about some recent artificial intelligence breakthroughs that we have enabled at the Pittsburgh Supercomputing Center. Let me introduce myself. My name is Paola Buitrago. I lead the Artificial Intelligence and Big Data Initiative at the center. With me is Nystrom. He's the interim director of the center. The center is part of Carnegie Mellon University. We are a joint effort of CMU, but also University of Pittsburgh, so we work tightly with both of these institutions. You want to? Sure.
Am I live? Yes, I just wanted to say thanks to everyone for coming. In the past, I've spoken here a couple times. We are both on the agenda for this talk. I'm here for maybe additional depth, but we weren't sure which of us could actually make it today, so we put two. And most of us could be Paula, so if I'm standing here looking silent, that's why.
So let me start with poker. So early this year, in January, there was an interesting competition demonstration on Texas No Limit Hold'em poker. We brought 4 of the top best poker players in the world. And what we asked them to do is to compete against Libratus, an artificial intelligence system developed at CMU. There was 20 days of competition where the top poker players were actively playing against the machine, and they had the opportunity to come up and get together and refine their strategy. It's jumping out. Refine their strategy and try to find ways to beat Libratus. And in the initial days, they thought they were going to be able to beat Libratus. This was not the first demonstration. Before this demonstration that happened on this year, there were a couple more 2 years ago and some other years ago, also developed by the same professor at CMU. And they were all, hopeful that this time, again, they were going to beat the artificial intelligence systems. This is how they progress across along the competition. In the final day, clearly Libratus was clearly superior, and it developed a strategy to beat this top poker player. So this is quite interesting in the sense that it's not as easy as chess or as checkers or Go, where you see the whole information of the system or of the problem and you can make decisions. Here, there is imperfect information. That's how we call this type of problems. There is incomplete information you don't know, and there is active agents taking decisions, like trying to fool you into making the wrong decision. So this is a great breakthrough in artificial intelligence. The results were demonstrated at 99.98 significance that Libratus was better than the brains, as they denominated the team of humans. Here we have the final results. It was 120,000 hands played. Parentheses indicate the negative number. If Libratus was playing in Vegas, so that means that Libratus would have won $1.8 million during this game. In this case, the demonstration, Libratus didn't get any money. There was $200,000 that were split among the players. So what made this possible? This is a breakthrough. This is a really interesting breakthrough. That was the next step or the next challenge after Go and checkers. What made this possible was clearly the work of Professor Thomas Sandholm at CMU and Noam Brown, his PhD student. But on top of that, since the problem is so complex, and to give you a sense of how complex it is, the space solution of a game like this type of poker is, it has a number of solutions that is 10 to the power of 161, which means if you count all the atoms in the universe, and then each of these atoms is another universe and has the same number of atoms that our universe has, that's still more than that. So that's the number of possible solutions for this problem. And it's highly complex, not easy at all. So on one hand, we need the expertise. We need people like Professor Thomas Sandholm, who dedicated his career, he has been working on this for over, 3 decades. But we also need compute and storage. Like, we need the capacity to really implement these algorithms and then process and store the knowledge base. So for Libratus in particular, it took 19 million core hours and 2.6 petabytes of knowledge base. What Libratus does, it learned from the rules, and it also learned from the games that it played against the top poker players. So, and a total at the end of the competition, this was all that Libratus have used. These are huge numbers, and this is what we provided for this demonstration at the Pittsburgh Supercomputing Center. The machine that made this possible was Bridges. This is the supercomputer that Nick talked about last time he was here at this conference. And this is how a supercomputer looks like, just to give a sense. It's just a computer with like string capabilities that at the end of the story, or at the end of the tail, what you have is a machine that is going to be faster at doing what you need to do. So if you have a certain algorithm or certain routines that require a lot of computing, if you do it in your laptop, it might take years, decades, sometimes hundreds of years. If you go to the cloud, you might parallelize it, but then in the cloud you incur in expenses, or you incur in time transferring the data. That's a common problem with big data. But if you have a supercomputer, it's like you can have all the data in a single place and have all the compute, and all the processing is done faster. To give just an idea of what's happening here, the nodes in the lower part are the actual compute nodes. So what's on red is traditional processors. These are Apollo 2000 compute nodes. And then what we have on green are GPUs. We have a pool right now of 100 GPUs. And then we have the interconnect, which is what makes one of the main characteristics of a supercomputer, and the fact that they can all connect and communicate really fast. On white, we have the storage. Bridges has in total almost 10 petabytes of storage. And here, just to mention how each of these elements come in place to make artificial intelligence and big data possible. So implement routines like deep learning. We have the GPUs, then have the large memory and Java and Python processes. We have these nodes that have up to 12 terabytes of RAM. So this is the kind of things that can make the difference between beating the top human poker players in a decade, or being able to do it in a month, or, well, reduce the times, and that clearly is a competitive advantage for anybody. Like, depending how fast you get to the solution, I mean, that's going to place you in a specific important point. So what's one of the best or most interesting aspects for Professor Thomas Sanholm for this particular research? It was completely for free. So at PSC, we make available all these resources for free with the disclaimer, go back, sorry, with the disclaimer that is for free when you're doing open research. So if you're doing something with us and your intention is to publish your results and make them available for everybody, that's something we can offer for free. For industry, however, we can also make available this huge machine, if you guys are interested, on a cost recovery basis due to the nature of our organization. So I go right here, stay there. So, no, doesn't want to stay there, okay. Libratus is just an example of a trend that we are seeing in artificial intelligence and also in high-performance computing. All the applications to be able to tackle their next challenges, of what's coming next, because they are so complex, because they involve so much data, because they require so much compute, they are converging or going to the intersection of having the right algorithms, coupling them with the right amount of data, good quality data, and also having the right compute resources and storage resources to make it happen. So there are a number of projects we are working on, and the Supercomputing Center we work with we have right now, this very instance, over 1,000 projects with different institutions across the nation. And this is the trend we are seeing. So what we have seen is that the next, what comes for the future, or the next breakthroughs that are going to be shaping the future of many fields and the future of humanity is at this intersection. And, well, Pittsburgh happens to be quite lucky, or how convenient the fact that you guys have this amazing resource that is the Pittsburgh Supercomputing Center, located right at the heart of Oakland, in between CMU and the University of Pittsburgh. I just want to show, like, this is some of the people that make the center work. We have over around 70 employees, and our mission is one of the 4 pillars of our mission is to improve the competitiveness of the U.S. industry, and in general, advance science and technology, educate and train researchers. I want to show you how we do this. We have different groups. 4 of them, like the top ones. There is a group dedicated on biomed. We have public health focus. There is a group of user support. So this is an important aspect. At the center, we are really focused on people that have never used a supercomputer or have never done artificial intelligence. We have people or the expertise to take new users and guide them through the process of really making the most out of what we have to offer. So if somebody is interested in working with us, there is not only the access to the hardware, but also to the expertise and the guidance and training that would be necessary to make the most. And there is this new initiative that is in artificial intelligence and big data. We just want to collect what we have been doing for years and make sure we are integrating and articulating the portfolio of services. On security and networking, when you're talking about big data, the transfer of big data, that becomes painful, can be painful. And also there are security concerns, privacy concerns that we all have. We have a team that has been working on these fields for a long time. For networking, PSC was part of the team that defined the protocols for internet. In security, our CIO is part of the FBI InfraGuard program that aims at training and defining the best practices for cybersecurity. So there is expertise, and we have articulated our offer in trying to really bring what we know how to do, supercomputer and data-intensive applications, and make them succeed, how to offer them to industry. So who works with PC? On the academic side, you guys will find all the common names, Harvard, MIT, Stanford, Berkeley. we work with them, but we also work with any academic institution, so high school or any academic institution that's just trying to, well, educate people. We can work with them for free. And then on, and then on the industry side, we have done stuff with NASA, Uber, Alcoa, ANSYS, some other big names. So the question is, we offer these great resources or these great services. How can specifically you guys come and work with us if you find it fit? So there's bridges. I mentioned this supercomputer. It was $17.2 million. We can, once again, make it available on a cost recovery basis. One of the most interesting aspects of this supercomputer is that you don't have to learn anything new about supercomputing. It's not like you have to train your stuff on supercomputing. Like, we offer the same tools that people normally use for this type of things. So R, MATLAB, Java, Python, for big data, Hadoop, Spark, all of that, it's already installed in the machine. So if you were to use it, it's not like you have to learn about the stuff, but it just will have a great machine making your processing faster. We also, on artificial intelligence, have all the frameworks. With 5 command lines, you can just run your own deep learning project. So this is that was the first option, going and using the supercomputer. On top of that, we have co-location. So if you want to have your own resources, but then you want to tap into the resources of the supercomputer, you can have, for instance, buy your own storage because you want your storage to be isolated, but have the ability to tap into the machine or use the supercomputing offer and maybe process it faster. So that's another way to use it. This can be also, well, use the expertise and do a research collaboration with our team. And eventually, if you want to buy more, to leverage the PSE purchasing power, we have been in close relationships with Intel, HP, and usually we get interesting benefits from that. The third way, or the third initiative I want to talk about today is the AI testbed. We have noticed it. We have noticed that there are many options and many decisions that have to be done when you are starting on artificial intelligence. You have to decide what hardware, what software, which of the frameworks that I mentioned. And the answer is not going to be a standard answer. There is not a single answer for everybody. It depends on your data. It depends on your particular problems and different factors that are going to be specific to your problems. So we have seen also that right now people think on NVIDIA and GPUs when they think on deep learning, but as we have spoken with vendors, there's going to be an explosion of offers in this field. What we want to offer is an environment where people will have early access to state-of-the-art technology that is focused on deep learning. So you would have hands-on experience and be able to pilot your particular model or your particular solution. And once you pilot your stuff, you can then go and make an informed decision and purchase your own stuff or go to the cloud if that's what you need, or co-locate. So it will be offering 3 different options, this particular AI testbed. So it can be like, if you want to only access the hardware, we can enable you to do that. If you need training, that's going to be also part of the offer. If you need somebody to work with you on developing the models or seeing how to, establish your whole stack, that's also something we can do. So tap into the human expertise that we have at the center. So that's the message I have for you guys today. And I see that I have 1 minute, so that's perfect. As a summary, we have seen, working with so many projects in big data or data-intensive projects, we have seen that there is this trend where the combination of the artificial intelligence or algorithms plus the big data sets plus the right computing is what's happening now, what's going to enable the next breakthroughs. Here locally, you have this amazing resource, and we are eager to work with you. We will be happy to work, and you guys can use any of these 3 options I described. So get access to the machine, or co-locating, or use the AI testbed resource that we will be offering. Thank you.